Yeah, right. Thanks for your introduction. Yeah, as you said, I will today talk a little bit about measuring the TOR network. So basically what you can measure, what you can see inside the network. So my talk is divided into parts. So I will first give you a short introduction and then go a little bit into detail into the measuring steps. So who am I? So it's quite common to introduce yourself. So my name is Kubieziel. I'm based in Germany, do IT security there, basically penetration testing and other kinds of IT security. Besides that, I'm a data protection officer. So Germany, as you might know, has quite strict data protection laws, and I help companies to have a good data protection inside their company. So, and I also do lectures at our local university. I wrote a book and did several other things. So, and if you like to contact me, I have a Twitter handle called Kubieziel and also a GNU social handle, which is the same, and you can also write me a mail. So, yeah, that's the thing. And yeah, first question to you: who of you has heard about TOR before? Hands up. Okay, so maybe the better question is, who has never heard of TOR? Okay, this was what I was expecting, basically. So TOR is quite well known inside the community, so you might know that TOR is the software and the protocol for protecting the privacy and anonymity of its users. It's also TOR is a network of relays, of bridges, directory authorities, etc. And that's also a thing where I come into play. So you might have heard of the organization called TORServers.net, and within this organization I also run some relays, some bridges, etc. So when it comes to TOR, I'm basically here somewhere in the middle with TORServers.net, and with TORServers.net there are lots of other organizations which do the same, basically. But TOR is also an organization, and right now there are like 40 sub-projects of all kinds. So TOR has grown quite large in the last few years. So I just will go through the how TOR works slides. I hope you have seen it before, but I will need some details later on. That's why I decided to show you those slides again. So you see here on the left-hand side Alice, who wants to connect to the TOR network. So, and as a first step, Alice TOR client goes to a directory authority called Dave in the left bottom, and downloads a list of all TOR servers, selects then 3 TOR servers, and then connects to those servers. So it makes a connection to the first one, and after that it goes like a telescope and extends the connection to the second and the third, and the packets go back and forth through this multiple encrypted links. And after some minutes the connection changes, and Alice will choose another circuit and so on. So that's the basic functionality. I hope everyone has heard of it. So if not, just raise your hand. So, and when I talk about TOR, the most user-facing thing I would say is the TOR Browser Bundle. As you can see it here, you can download it at the TOR website, and it includes a patched and rebranded version of Mozilla Firefox, the TOR software itself, TOR button, and no script, and tries to protect the user basically when it goes to the net. But there are some sub-projects, some of the 40s are called TOR Messenger. For instance, TOR Messenger is an instant messaging client which was published recently. Also, there is another instant messaging client called Ricochet. So TOR Messenger uses the XMPP protocol and other protocols. For instance, you can use it with several protocols, while Ricochet uses this so-called hidden services for instant messaging. So it has another approach. So also when you use some mobile phone, there's ORWord with ORFox for Android. There's an Onion browser for iPhone. So you can use it there. Or if you want to share files, you can use Onion Share. And this Onion Share software also opens a hidden service, and you get some quite unguessable URL, send it to the other party, it downloads the software, and then the hidden service closes again. So that's also an idea. And there are, as I said, quite a lot of other sub-projects. I just wanted to mention some of them in my introduction. So, and besides the part of anonymity, TOR also works in the area of censorship resistance. So TOR receives quite lots of funding to develop censorship resistance. So the idea is that the software works in countries with quite heavy censorship. So you can go to China, to Iran, to several other countries, and use the TOR software there. And the approaches are called bridges. So bridges is the basic idea. And on top of that, there are so-called pluggable transports, which obfuscate the traffic so that the sensor isn't able to decide that you do some things he doesn't want, basically. So, and especially in China, this OPS4 thing, which is here on the right-hand side here, works quite reliably. Also Scramble Suit and other approaches work also good in other countries. So that was my short introduction in the TOR. As I expected, most of you have already heard about the software. And now I will go a little bit more into detail what it means to measure the network. So I do quite often talks about TOR. I teach people about TOR, talk about TOR, etc., etc. And I often hear some questions. So some people want to know how many users does TOR have, where the users come from, and also, well, one of the most asked questions is the middle one here: why is TOR so slow? Yeah, these are some questions which come from the user side. But since 2013, I often heard the question: well, how many relays does the NSA run? How many relays does the GCHQ or any other intelligence agency? And also there are some other kind of questions. So, and this question needs some answers. The user demanded an answer, and so to answer those questions, you need to measure the network. You need to do measurements here, and that's why everything began. So the first ideas when it comes to measuring are quite old. They're like 7 years old or so. But the main thing is, well, on the one hand side, you have an anonymity network. And well, how will you do measurements without hurting the anonymity of the users? This feels like a contradiction, and I provided a small example to show you what TOR is thinking about, what they do here to protect the user. So the idea here is to answer one of the first questions: where do the user come from? So basically, you want to know what countries the TOR users come from, and yeah, you want to measure those data without hurting the anonymity of the single user. So first of all, you need to get an idea where you can extract those data, and basically there are two points where you can extract the data. So the first one is the entry node, the first node in the network. So that's this one here. So, and since several years, the design has changed a little bit. So this slide here showed you the TOR connection, and when I switched to the next slide here, you saw that also here the entry node changes. This is an older slide right now. It's so that the first node, the node here on the left-hand side, stays the same for quite a while, because this is done to prevent some attacks, and so TOR switched to this so-called guard node design. So when you connect to TOR network, the first node stays the same for several weeks, and then it will change. So and of course the first node sees the real IP address of Alice, because, well, it needs to connect to the first node with its real IP address. So what you can do basically is just ask the guard node, the entry node, to store in some way the IP address and then analyze this data. So that's the one idea. Another idea is to ask the directory authority. So this node here to look which client came there and downloaded the list of servers. So this directory authority will also see the client of Alice. So these are the 2 points where we can gather some data. So as I said here, the clients get their network view from the authorities, and yeah, you need to somehow recognize the TOR clients. But in the current design, it's also so that you can set up your TOR relay to be a directory mirror. So it means your relay, your TOR server, also mirrors this directory information. So the client of Alice here, go back to this slide here, doesn't go every time to Dave, but it can also go to this node, for instance, and ask it for directory information, and also this node can handle it over to Alice and give it to them. So there are some possibilities to hand over directory information, and all those nodes have the ideas. And as I said, entry nodes, these can be guard nodes or bridges, and the guard nodes see by design the client's IP as well as all IPs of other relays. So an entry node can also be like a middle node for other circuits, etc. So if you want to ask the guard node, you have to decide if it's a well-known TOR relay or if it's a not known relay, and in the last case, then it must be a client. So, and also a bridge. Bridge is like the first entry into the TOR network, only sees client's IPs. It will never see other IP addresses. So you can collect it at some points. So now we have identified the collection points. So and the another and quite more important question is how to do it right. So how to collect those data without hurting the anonymity of the user. So the most obvious way, or the naive way, I would say, to do measurement would be the following: just collect every IP address at the directory authority or at some entry node, send it to some central server, and the central server does analyze all the data and puts out a nice graph or something like that. Well, but I think we can, if I ask you, we can sit here for the next hour and think about all kinds of attacks, because this approach is so vulnerable. I think every one of you will find some attacks, and we can basically de-anonymize the user. So that's not the right way to do it. So we need to think about other ideas. So basically here, what you see on the right-hand side, this is the graph of the directly connecting users since 2011, so over the last 4 years. And you see here, first there were something below 1 million users per day, and then we saw a huge jump, which happened somewhere in 2013. And then the numbers went down. So, and yeah, it was like in the middle of 2013. And when you think about the Snowden revelation, they were also at the middle of 2013. And you might come to the conclusion, well, this was because of the Snowden revelation, but that's not true. It was not because of Snowden, but because some Ukrainian guy set up a malware botnet, and we wanted to use a TOR for internal communication. So basically, what you see here, the jump in user numbers from like below 1 million to more than 5 million, was a botnet. And so after some time, this botnet was cleared. They deactivated the client, and so like I think here at this point, there were more or less more real user numbers again. But Microsoft tells that there are also some clients, some botnet clients out there. So it's not really clear if this the real user number or what the amount of botnet users are inside here. So another approach, another idea would be just to collect the IP and instantly geolocate the IP address, because the only thing you want to know here in these examples is where does the the TOR user come from. So you don't need the actual IP address, but you will only need the geolocation. You will only need the country where this IP comes from. And so you can basically do this, just look at the IP and make a geolocation. And like since 2008 or 2009, TOR comes with a geo-IP database, so you can do it on the side of the, in this case, so-called client. So this would be fine. So you can geolocate immediately, but then you have to ask yourself what happens if there are duplicate IP addresses. So how do I find out duplicate IP addresses? So there is a necessity to store somewhere the IP addresses to remove duplications. You can do it in RAM, and after some time, just write this geolocation data onto the hard drive. That's a basic idea. So, but then the next question arises: what happens when there are countries with few users? So you see here a graph. They're directly connecting users from Vatican City. So the Pope and his staff obviously use TOR. So and there are like 5 to 10. So here's 0. That's the 0 line. That's the 5 line, the 10 line, and the 15 line. So you saw between like nearly 5 to 10 users, daily users, are from the Vatican City. And yeah, when you have countries with few users and you push this information quite often, so like once per hour, for instance, or once per small amount of hours, it would be quite easy when an attacker gets this data and goes back to see who maybe was using TOR at this point, and also you need to have some countermeasures here. So one countermeasure in this case is just to collect all the data over one single day, so over 24 hours, and collect it then. And also there is a try to obfuscate the number of users, because the number of users are rounded up to a multiple of 8. So that you don't see that you had only one single user at a given point in time. So the minimum amount you usually see is 8. So the goal is to obfuscate it a little bit in face of the attacker. So in the end, you can then do, for instance, this nice thing here. So some guys from the University of Oxford did this nice graphic here. So they showed the amount of daily TOR users, and so you see here the USA, Canada, this is France, Spain, Italy, Germany. This one is Austria. Here is Switzerland, Czech Republic. Here's Iran, which is also quite a huge part. Russia, Ukraine, etc., etc. So you see here some nice graphic who is using TOR. So this is quite, one of the results of these ideas. So and TOR over time has then worked out several principles when collecting statistics. So they said, well, first there are some legal requirements. So in several states we have wiretapping laws, we have data protection laws, and we have to make sure that we don't fall under any kind of wiretapping law, because it would be quite bad. And also we have to make sure that we don't fall under some data protection things. So we have to take care about several legal requirements. Of course, the privacy of the user is quite important for us. We have to take care that we don't accidentally de-anonymize any user. And also when it comes to university research, it's quite often the case that you need the approval of the IRB, of the Institutional Review Board. So they, if you do some research and want to do it in an ethical, responsible way, you go to the IRB guys and they look what you're doing and then approve it or don't approve it. So in psychology and in medicine, it's quite common to do this. In computer science, it's not really that common, but at least from the US side, I think it's getting more and more common. yeah, and in the end, so you can have like a research which is which fulfills every legal requirement, which is ethically approved, but you also have to think about what the user thinks about this. So at the end, maybe the user finds it not so good that you collecting every kind of data. So what TOR tries to do is to publicize what they are doing, so that everyone who wants to know it also can know it and can have a like informed consent, and is not surprised that TOR also collects and measures some data. So that's some principles when it comes to collecting data. So and as I said, there are different roles when it comes to TOR. So and every kind of role asks different questions. So there are some end users which just download the TOR browser, use it, and they want to know other things than, for instance, operator of a directory authority or relay operator. And the measurement team, which is inside TOR, developed several tools to give answers. And one of the important portal, I would say, is the TOR metrics portal. So when you go to metrics.torproject.org, you get here to this site, and here you find all kinds of possibilities to look for some statistical data. So you can, for instance, find here the number of relays and bridges inside the network, or here the number of directly connecting users. So this was the first one. This is the number of relays and bridges of inside the network. It's quite easy to find out. So you just need to parse this directory authority data, and you see that there are like more than 6,000 relays currently inside the network, and something above 3,000 bridges inside the network. So that's quite easy to do. The other thing is the number of directly connecting users. As I said, this was the thing where my example started. So currently, the estimation is that there are more than 2 million users worldwide per day. And if you say, well, I want to know about the Austrian users, I can also ask for Austrian users and see, well, users from Austria are like 50,000 at the moment currently. And the data goes back to 2011. So you can also change here the date to 2011 and see how the number of users developed over time, over the last several years. So there is also data from before 2011, but the algorithm before had some mistake in it and did it the wrong way. That's why we only find data starting from 2011 here. So in TOR metrics, you find all kind of nice data here. Just if you have time, just browse around. I don't want to show everything here. So, but let's say I'm an end user, the first role, and one of the important questions this kind of user asks is, am I really connected to TOR? So that's one of the first questions to him. And there is also a website here called check.torproject.org. This was the page which was shown by the TOR browser some time ago. Right now you see another kind of page. So when you open the TOR browser for the first time, you see this page. It's my TOR browser is set to German, so it says, well, herzlichen Glückwunsch, so welcome. This browser does use TOR. And when you click here on TOR, check the network settings, then it calls this check.torproject.org page and shows you that you are connected with TOR. And if you're not connected, you see basically here this screen below. And behind that, there is a software called TORDNSEL. It's a library written in Haskell. And this Haskell library basically looks at the directory data and then looks at the IP, which is connecting to the check site, and says, well, you're connected, you're not connected. And it also tries to find out if the user comes with a TOR browser version or with TOR and a non-TOR browser version, and also shows here a warning. So in the future, there should be another library, TOR Bell. This is a rewrite of TOR DNSEL, which does basically the same. So this TOR DNSEL and TOR Bell running in the background, and the thing which you see is the check TOR Projectorg site. And as I said, what the user quite often asks is, why is TOR so slow? So they try to use TOR, and then they say, well, oh, this is quite not so fast to use. And at some points, the developer said, well, we need to find out how we can make TOR faster. And and here also you need data. And what they are doing since several years right now, they just try to download a 50 KB file and also a 5 MB file and measure the time, how long it takes to download this file. So you see here a graph starting also in 2011, going to November 2015, and you see the time which it took to download it. So this is the time in seconds, it must be in seconds. So here in 2011, it took like 50 to 150 seconds to download the file, and then over time, right now we are down to, don't know, 10 to 20 seconds for a 5 MB file. And here, this is a 50 KB request, which was something between 3 and 5 seconds, and it's also down to 1 second right now. And so this measurement helped the developers to find bottlenecks inside the networks, to improve the algorithms, and to make it faster. And you can see over time it really improved. So TOR is getting faster, but of course it's still maybe a bit slower than normal browsing. So this is not really a measurement for the end user, but in the end it helps the end user to get a faster connection. Another role here is the relay operator. So this, I would say, an integral part of the TOR network, because they run all the relays, they run servers, bridges, etc. And of course, such a relay operator has all kinds of questions. So the first questions when someone decides to be a network or a relay operator is, where should I put my relay? So the first, most obvious question is, maybe in the country where I am. So if I am an Austrian citizen, it might be a good idea to open a relay in Austria or in Germany or in any other country. But what you see here is the so-called Bubblecrafts, and this is the distribution over countries. I can also try to show you it here live. So it needs some time. So there, at the TOR metrics page, you find this network Bubblecrafts. So for instance, you can say, I want to see exits, and they should be grouped by country. So you click here on this link, and wait for some time, and then those Bubblecrafts pop up. So that's the thing which I also had on my slides, and here on this site you can now go to this bubbles and see, well, this is Luxembourg here, this is Switzerland, United States, this large one here is France, for instance, Germany, Romania, etc. So France is the case because there's a huge provider in France called OVH, and several people have their relays running at OVH, and that's why here the bubble from France is so large. You see Netherlands is quite large. And I also tried to find the same thing for Austria, but there is no bubble for Austria because Austria only has a handful of relays, so you won't find it here. So then this Bubblecraft thing here also can help to say, okay, it might be not so good idea to have my relay in France, but maybe somewhere here in Moldova, which maybe have a good offer right now, and so you can set up a server there. And what's also quite nice is there's, so you maybe cannot read it, there's a site called compass.torproject.org, and here you can have a list-like thing of the distribution of TOR nodes in a country, or you can also select it via AS, for instance, or via some other things. And so this should be helpful for the relay operator to decide in which country to put your node. because the goal is to have like a diverse network. So you maybe saw it in the beginning here, is this Toolflow site, which also uses some older data from the TOR project. And this is not real-time data, but those data is from end of October this year. And you see here there are lots of traffic here inside Europe. So you see here the large France bubble, large German bubble, and you see that there's some traffic going back and forth to United States, but a lot of traffic is here. And it might be a good idea to have some nodes in other countries to distribute the network a little bit better. So, and after some time, you set up your relay, and it works. And you might want to check if this is really useful right now, if it like helps the average user. And this is what you can see here. So there are two sites called Atlas and Globe. You can reach it at atlas.torproject.org and globe.torproject.org and enter the name of your relay or some identification of your relay, and it shows you some information. So I just chose one Austrian relay here and took the graphs from 3 months. You can see here this relay was started at the end of October, and then it just collects some traffic. In the beginning it was quite low, and then it gets higher and higher and higher, and right now this relay is at around 4 megabits per second on traffic. And what you can see here on the second graph is the so-called exit probability. So when the relay was started, it was set up as an exit, but TOR, the TOR software, didn't consider it as an exit, doesn't use it as an exit, but only use it as here a middle relay. So you see here the yellow line is the middle relay probability, and the red line is the guard probability, so the probability that it will get a guard, so the first node into the network. And after some time, so after nearly a month, this node gained so much trust from the TOR protocol, I'd say, that it was an exit, so it changed to an exit relay. So and TOR gave it exit probability, and now it can be used as an exit. So the lifetime of such a relay was described in a blog post. So if you want to know more about the lifetime of such a relay, just go to blog.torproject.org and you find a description what TOR will do with such a relay over some time. So it needs to build some trust at the beginning and so on, and at the end it will be used. So, and now the operator has a running exit relay, and it can be used for any kind of traffic, of course. And TOR offers for exit relay operators that they can get a nice T-shirt. So not this one, this is quite old, but you can get other T-shirts. And so after some time, there's another measurement program called Weather, TOR Weather, which looks for all existing relays. And at some point, when you're eligible to get a T-shirt, you get a mail from this weather software, and which tells you, well, you now can get a free T-shirt from the TOR project. Thank you for running the relay. Please write a mail to this and that address, and then you get a T-shirt. So this is also part of the measurement things, this TOR Weather program. And currently there's another software in development called TorStore, which probably will take over this functionality, because TOR Weather is, from my point of view, quite simple. It's a Python software, but nobody really maintains it anymore. And so it was decided to drop it. But currently it also runs. Yeah, and also if you're running a relay, and especially an exit relay, at some point some law enforcement agency might come to your house or to your office or send you a nice letter or whatever and say, well, I saw you did a bad thing. You hacked the forum, you did some strange things. And you said, no, I didn't do this. But, well, I run a TOR relay, maybe some other random guy did it. Well, the police say, well, prove it. And what you can do here, where also TOR helps, is you can go to another website. It's also part of the measurement things. The site is called Accelerator. And this website tells you if a given IP at a given time was a TOR relay. So so this was the TOR browser site, but here is the Accelerator site. You just enter some IP address. I haven't prepared anything, and a date, and say, please look if this was a relay. Okay, and and here in this case it says, well, I haven't found anything. But I just visited somewhere the check site. Maybe I find it here. So I can just copy this address here inside and say if this was an exit relay at this point, but it was also not a relay. So go back to 2015 and let's say some days earlier, so the 13th of November, and just wait a moment, it just looks for an entry. And right now this IP address, as we saw, was a relay, and now we should get another answer here. So now you see the TOR has found something, and here at this page you can see, well, at the 12th of November we saw this was a relay. The name was DigiGuessTOR2E1, etc. And so on and so on. So it gives you some information, and so basically the police can go to the site and question if this IP address was a TOR relay at a given time. And as far as I know, for instance, the FBI does use it quite a lot to find out if an IP was a TOR relay or not. So and another role inside the network are the directory authorities. So the guys who run the listings of all TOR relays, and they need to take care of the network itself. So they need to find out if there are some bad guys. So what they are doing, they try to find out if there are cyber attacks out there. So if there are some relays doing some injection of JavaScript or do some other kind of stuff. And there was a software written called Cyber Hunter, and this constantly runs in the background, tests several relays, and if it finds some relay which injects some strange things, it sends a message to the directory authorities, and then they might decide to block this relay. And also there are some misconfigured and also some other kind of malicious relays, and there's another software called ExitMap, which also runs in the background, tests those servers, and so try to find out if there are some malicious relays and then block them. So you can run all those software on your own. I have linked them on my slides here. You can find them also on GitHub repositories, and try to find out if you can find some malicious relays on your own. And well, if you found a bad acting relay at some point, what I would recommend is that you contact the TOR project. So there is a mailing list called Bad Relays. Send a mail there and said, well, I found a bad relay. It has the IP address something like that, and it does this and that bad thing. And the operators will try to find out if it does really bad things, and if they think so, they block this relay, and nobody will use it in their TOR connection. So there's also a wiki page which explains a little bit more how TOR deals with bad relays. So TOR tries to find out bad relays and keep the network healthy and clean, basically. Yeah, and TOR metrics has quite lots of data available. So here is this collect TOR site, and if you are interested in discovering some own things, own statistics, own things, you can go to the collector site, and you find all kinds of data which was collected over time from the TOR network. So you find all relay descriptors, you find other kind of things all back to several years, and can do several things. And also, if you're a Python person, TOR has a library called STEM, S-T-E-M, and you can use this STEM library to work with these descriptors here and do all kinds of stuff which you like. So this collector site is quite helpful and quite usable. And so the metrics team, which is inside the TOR project, does quite a lot of development, tries to measure several things and well, to provide you with some more insights of the network. So basically, if you want to know anything, just go to the TOR metrics site, to this one here, you find several answers. And well, if you don't find an answer, write a mail to the TOR project and ask, and we will try to give you answers. So I hope I gave you a short overview, a short insight into the measurement tasks. Yeah, and if you have any questions, please ask and as well. And thank you for listening.
Any questions regarding the pretty graphs? Yes.
Thanks. Do you have a quick question to maybe something like the accelerator to checks whether an IP, but it is shell-based and quite quick, so I can use it in an automated blocking procedure? It's like a geo IP, I can easily...
Well, I don't know a shell-based solution, but what you can do basically is go to the collector site and download all old descriptors and then have a cron job which also downloads the new description and then write your own program which works on this data, basically. So then you have to build your own. I don't know.
Quite solve my problem, but we'll discuss this after.
Okay, so I misunderstand you probably.
Problem is, for example, I recognize attacks on my firewall, want to block this IP, but I would like to look whether it's a TOR relay before I block it, so I won't block it if it's a TOR relay.
Ah, okay, yeah.
And I would like to do this automatically in the background somewhere without much effort.
Yeah, possible. There are some people out there which do this, so there's... just forgot the name, I think danme.co.uk. So this guy does the same. He offers you some kind of library which you can insert in your web application, basically. Or if you if you use Cloudflare, for instance, they also try to find out if there's a TOR relay and if it does some malicious things and then blocks you. Or they actually don't really block you, but they show you a captcha. And you have to solve the captcha and then go to the page. So... there's a page I have to look it up. So I think it was danme.co.uk, but I'm not really sure.
Maybe there's a tool that compares IPs against the current consensus files. Maybe somebody already wrote that.
Yeah, maybe.
That would be useful. Yeah. There was a question? Yes.
Hi, I'm very struck that there was a parallel operation doing pretty much the same metrics in real time. You've probably read about it. It's at the headquarters of the NSA. It's called Ronin, and its target is to produce every hour in the National SIGINT Operations Center a TOR exit node map and to get such metrics as they can. The famous, I think it's famous to everyone here, TOR Stinks paper that they did with our friends from GCHQ in Yorkshire shows how desperate they were to find ways to de-anonymize. But that paper was 3 years ago. They're still working on it. Their concern is very clear. What I'm wondering is, in a cyber defense context, if you are setting any goal to protect anonymity of the user base, if that is a core goal, and I don't know, that's a question. And the second thing is, if you have awareness, as you would, that there's the dark side or the light side, however you see it, out there, running the same metrics to try and attack the anonymity base, are you trying to shadow what they're doing to spot the weaknesses and flaws? And if so, how do you approach that using the tools you've told us about? Sorry, long question. Hopefully it's comprehensible.
Okay. So it was more a comment than a question.
No, it's a question about, are you taking on it's a question about, do you have a policy goal to protect anonymity? And are you taking on, in effect, a cyber defense role, actively using your metrics to see what their metrics are seeing in order to modify routing or other instructions within the network? So it's two serious questions.
Okay. So the first thing, the policy questions, I hope I answered it in my, no, it was not here. At some point, I have to just find it in my slides. Here it is. So this is the basic idea here. So the TOR tries to look after legal requirements that they don't fall under several wiretapping laws, under data protection laws, etc. They just also look when they're collecting data that they don't accidentally de-anonymize user in some way, and so they try to do it look it from this perspective, and all the data which are collected, which I showed you in the other slides. So the data collection is done at the directory authority and instantly is geolocated, for instance. So if there is some NSA who has this NSA has to attack the directory authority server, but when they are able to attack this kind of server, they have such a huge amount of data that those metrics data is basically not interesting anymore for them. So that's why those directory authorities are run by persons who have a high proficiency in IT security, who look at the systems and try to protect them against any kinds of attacks. On the other side, so we don't really know what the NSA is doing at the moment or what they are thinking. So there are some guys inside the TOR who try to find out what the NSA is thinking about and then try to build defenses against it. But we don't actually have an idea what the NSA is doing. So maybe so that's the only way I can answer it here. So, but there are some people are trying to think about possible attacks, possible weaknesses in the client, and then try to find some attacks against it.
Thank you for the pretty graphs and the insights on the TOR metrics.
Thanks for listening.